All right, today we are going to look at some application problems using our trig functions that we've been looking at. So with these application problems, we have these terms that we're going to hear. One of those terms is angle of elevation here, okay? And looking at our diagrams, you'll see it says here's the observer's eyeball. So you think about a person that's standing here, okay? This is their head. Their feet are down here somewhere on the ground, and this is their eyeball. And if they were to look straight out, that would be their horizontal line of sight. So this we would think about is parallel to the ground. Okay? Now, if we have an object, let's say we have a tree, and there's a bird up in the tree, and the person looks up at the bird here, they've now adjusted their line of sight to be here. All right. And then we have this angle here that goes from their original horizontal line of sight, if they were to just look straight across, up to their new line of sight where they're looking. Okay, so I'm gonna jot a note down in here that theta, that's that angle there, is looking from the line of sight, and by line of sight right now I mean this purple one here, the horizontal line of sight up to an object. Okay, so you'll notice that's where the arrow is going there. So that's angle of elevation. Now, very similar to that, we have angle of depression. And it doesn't mean it's sad. Okay, so again, here's the observer's eyeball. So here's their head, their feet are down here somewhere on the ground. Okay, if the person were to just stand straight and look straight across, this would be their line of sight here, which again, this would be parallel to the ground. Okay, now if we have an object lower, so now maybe we have an object down on the ground or something, then the observer is going to have to look down, and this would be their new line of sight. Okay, and so now we get this angle here, which is called the angle of depression. Okay, so we're going to say theta is looking from the, and I'll specify this time, horizontal line of sight down to an object. All right, so angle of elevation, you're looking up to something. Angle of depression, you're looking down. And remember, we're always comparing it to our straight across, our horizontal line of sight, which is always parallel to the ground. All right, so let's look at these application problems here. All right, and it does say to draw some sort of diagram here. So the angle of elevation to the top of the Empire State Building in New York is 11 degrees from a point on the ground, 1 mile from the base of the building. Find the height of the Empire State Building. So let's think about this. So if that's my Empire State Building, okay, I have a point on the ground that is 1 mile away from the base of the building. So I've got a point over here, and this is going to be 1 mile. Okay, and we're going to assume that the building and the ground would make a right angle. Okay, and I'm going to complete this triangle here. And it says that the angle of elevation to the top of the Empire State Building. So again, angle of elevation, remember we're going up. So that would be this angle here is 11 degrees up to the top of the Empire State Building. Okay, and now we want to find the height of the building. So that's our x. So it looks like, based on this angle, it looks like I'm not using the hypotenuse at all. So I have opposite and adjacent. which is our tan function. So the tangent of 11 degrees is the opposite, which is x, over the adjacent, which is 1 mile. Now, I'm going to think about this for a second because I don't really want to get the height of the building in miles. I'd much rather have it in feet. And I know 1 mile is 5,280 feet. So that's what I'm going to use because then my answer will be in feet. All right, so I can multiply both sides by 5,280. X equals 5,280 times the tangent of 11. And then I'm going to grab a calculator. First thing, I'm going to look, I'm in degree mode, so that's good. So 5,280, tan 11, and I get X is approximately 1,026.3 feet. Okay. All right, number 2. From the top of a 200-foot lighthouse. So here's my lighthouse. I know it's 200 feet tall. The angle of depression to a ship in the ocean is 23 degrees. All right, so from the top of this, I've got a person up here at the top of my lighthouse, and down here somewhere, I've got this ship or a little sailboat. Okay. Now, the person at the top of the lighthouse, if he were to look straight out, here's his line of sight, right? But he is going to take his eyes and he is going to start looking down to the ship. So here, we actually have to think about, we kind of want to draw in this line of sight. That's supposed to be a down arrow. Okay. And then we've got this distance here. Okay, so his angle of depression, it says, is 23 degrees. Okay, and it wants to know how far is the ship from the base of the lighthouse. So this is X. Okay, so there's a couple of ways that we can solve this problem because notice, first of all, the 23 degrees is not even inside of our triangle. Okay, so there's two ways I can think about this. One way, remember we talked about the original horizontal line of sight would be parallel to the ground here. So I know these two lines are parallel, which, remember back, this is a transversal, right? I know you didn't think those things were coming back, but we have parallel lines, we have a transversal, and right here, I have alternate interior angles, right? They're on different sides of the transversal, they're in between the parallel lines, and because the lines are parallel, I know that this angle would also have to be 23 degrees. Okay, so that's one way. It's kind of a mess. To think about it. The other way is we know that because the two lines are parallel, we also know this would have to be a right angle. And so we could do 90 minus 23 to get the other angle up here. That's another option. All right, but I'm going to go with what we have. So again, it looks like we're not using the hypotenuse, so I'm going to use tangent again. So tan 23 is equal to the opposite over the hypotenuse. Okay, remember you can put this over 1 and you can cross multiply. So x times tan 23 equals, here we have 1 times 200, which is 200. I'm going to divide both sides of the equation by tan 23. X will equal 200 divided by tan 23. And on my calculator, 200 divided by tan 23 gives us 471.2 feet. Okay. All right, and last problem here. A 20-foot ladder leans against a building. All right, so let's go. Let's get a building here. We've got the ladder. I know the building and the ground make a right angle, and it's a 20-foot ladder right here. So this is 20 feet. So that the angle between the ground and the ladder, so here's the ground, here's the ladder. So this angle here is 72 degrees. How high does the ladder reach on the building? So we want to know this side. All right, so it looks like based on this angle, I'm using the opposite leg and the hypotenuse. So that would be sine. Sine of 72 equals the opposite over the hypotenuse. I'm going to multiply both sides by 20. And I get 20 times sine 72. And 20 times sine 72 is 19.02 feet. All right, let me know if you guys have any questions, and I hope you have a great day.